Okay, this video starts a third example on finding variance and standard deviation. With this particular example, I wanted to look at using a graph and finding the data from the graph, being able to read that information from the graph. So we have a graph that's showing the number of workers from different countries, and we're going to collect that data from the graph. So again, we're going to make a chart of our data items. So we have 778 million workers from China, 472 million workers from India, 147 million workers in the US, 106 million from Indonesia, and 82 million from Brazil. So that is collecting our data from a graph to get us started. And now we want to find the variance and we want to find the standard deviation. So just like we have done in our previous examples, we want to make a second column, and we are going to calculate our data value minus the mean. And I've already calculated the mean to be 317. So 778 minus 317 is 461. 472 minus the 317 is going to be 155. And then 147 minus 317 is negative 170. 106 minus 317 is going to be negative 211. And 82 minus 317 is going to be negative 235. And it's always that data value minus the mean. And that's why you're going to get some positive values and you're going to get some negatives. Again, just as a reminder, if we added up this particular column, we would get 0 as the result there. And that is why we do the squared column. So we're doing x minus the mean squared. So we're taking this answer in that second column and squaring it in this third column. So we end up getting 212,521, 24,025, 28,900, 44,521, 55,225. And then last but not least, we want to find the sum of that particular column. And that turns out to be 365,195. And so now we're going to use that information to calculate the variance and the standard deviation. So the variance is going to be 365,195 divided by the number of items, which is 5, minus 1 makes 4. And so that gives us 91,298. And then the standard deviation will be the square root of that. Which turns out to be 302.16. And of course, since we're talking about people, we probably should round that to the nearest whole number, 302. So there's another example of how to find variance and standard deviation. So we've gone through quite a few examples of how to find variance and standard deviation. And I've tried to look at a sample of different kinds of problems and do multiple examples, so you have lots of things to look at in terms of practicing that. Now I want to just go through some information about items you should remember about using variance and standard deviation, some facts or pointers to remember about these particular things. Ever how you want to label this. things to remember, facts to remember, information to remember. So our first item here is just to remember that the standard deviation is a measurement. And it is a measurement of variation, or a measurement of dispersion, or a measurement of the spread. And it does include all the values in your data set. And it is including the variation from the mean. So it includes all values. The variation means how much is it spread out, and it is including the mean. A second fact to remember is 99% of the time the standard deviation should turn out to be a positive value. It is very, very rare that the standard deviation does not turn out to be a positive value. So if you don't get a positive number, that should tell you that you're doing something incorrect. A third thing to remember about standard deviation is that it is not resistant to extreme values. Not resistant to extreme values. Now, what does that mean? Not resistant means the high and low values, or the outliers, is going to change the value. Of the standard deviation. Another item to remember is that the standard deviation uses the same units as whatever the data values are. Whereas the variance uses square units. The use of the standard deviation is that it is trying to find if you have normal or typical values. And whether that extreme value is large or small, it doesn't really matter. But it's going to help you try to decide whether they are too large or too small. When you are using standard deviation, you have to be careful about comparing two different data sets. When there are two different data sets, you need to be sure that the mean is near the same amount. If the means are not near the same values, you're not going to get a very accurate comparison. And if they're not, you want to use a value called coefficient of variation. And that coefficient of variation will use the standard deviation and the mean and the percent to help come up with a value so that you can see how they actually do work together that way.